Hello, today is Monday, March 21st, and for today, when you get into our folder, our daily question is for you to tell me if you are present or absent. It's essentially a freebie for today. After we did our daily question, we moved into a note situation today. The notes we went over today were talking about the formation of the periodic table and the process it underwent. So I'm going to quickly go through the presentation which you have in front of you. These are the notes that I would take if I was a student listening in on this presentation. So we have Dobener's triads. In 1929, the German chemist J.W. Dobener classified some elements into triads. He did this because during his experiments, he noticed that some of them had very similar chemical properties. And remember, chemical properties are not things that are just physically apparent. So he noticed that some elements would react to water a certain way, to oxygen a certain way, to acids a certain way. He noticed that if you lit them on fire, they behave differently. Um, and when he did those observations, he also noticed that physical properties varied in an orderly way. In other words, their physical properties went up a certain way, went down a certain way, based on the atomic mass of the elements. Now, he was followed up by Dmitry Mendeleev, and Mendeleev was a Russian chemist, and he actually is the one that we really credit with the table of elements. What he did was he noticed that, yes, the properties of elements are related um, to their physical and chemical situations, and that they do go in an orderly manner according to atomic mass. However, he noticed that if he laid them out in rows, that the properties would be repeating themselves over the number of rows for a certain period of time. And then you would go drop back down and it would have the exact same situation. So he realized that if I started off on the far left, I would have very unstable elements, highly reactive. But when I would get to the far right, I would have elements that would be very stable, not very reactive. And then he also noticed that elements in the same column would have very similar properties overall. Now, these observations led to a lot of wonderful things happening. Um, Mendeleev is credited with having a very significant development to chemistry. And this is because when he showed that the properties of the elements repeat in an orderly way from row to row, he realized that there was a periodicity. And a periodicity is a tendency of things to happen at a regular interval. The moon has periodicity. The tides have periodicity. Seasons are periodicity. All right. So this allowed for him to have a situation where he could test out and make sure that his periodicity observations were correct. So what he did is he had blank spaces in his periodic table that allowed for him to go ahead and try out and see if he was right. So he would go ahead and say, hey, this blank spot in this particular part of the periodic table is going to have the following traits in its element. Its element's going to have about this many number of protons, and it's going to have this type of atomic mass. Well, over time, he was proved correct with the discovery of new elements. And so on our periodic table, when we see absent spaces, those are areas where new elements will appear. Now, he was very confident and he started strictly arranging them by properties rather than by atomic mass. And if we'd done it by atomic mass only, we would have had a different arrangement. Now we're going to move on to what are the ions. Now remember, ions are going to be situations in which there's a different number of protons and electrons than the the main element. If I have a positive charge, I have more protons than electrons. That means that I've probably lost an electron or two. If I have a negative charge, I've probably gained an electron. So I have more electrons than protons. So group 1A, which is hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, they will have for ions a positive 1 charge. In group 2A, we have magnesium, calcium. They would have a positive 2 charge. Come over here to group 5A, they have a negative 3 charge, group 6A, negative 2 charge, and group 7A, a negative 1 charge. Um, Please bear in mind that these are the normal trends for that. These are going to be their go-to ionic states. So here are some other setups of the periodic table. We have our alkaline earth metals, our alkaline earth metals, transition metals. We have our lanthides, and actinides, and they are located down here in the rare earth and man-made metals. Back up here, we have our halogens. We have our noble gases. This one right here breaks it down and gives you a little bit more to look at. All right. Elements and groups react in similar ways. That's something really important to keep up with. In group 1A, the alkali metals, some of them will have strong reactions with water. Some other things that we should notice about this group right here is that they're also very soft. All right, the alkali metals are. Now, when we get to the alkaline earth metals, we're going to see right here that they should be able to catch fire, that they have a very specific structure. Group 7A, the halogens, these are our salt makers. So fluoride, chloride, bromide, iodide, acetane. All right, those are going to be ones that do that. Then we have our noble gases. We could also call these inert gases. These are the ones that are very light. They make up neon signs. They're very unreactive because they have full valence electron shells. Okay, and then with the transition elements, right here we have our lanthanides and our actinides on the rare earth metal and man-made metal section. Once we have finished these notes, we went ahead and we did this activity coming up, and this one is for a grade. So I'm pulling the assignment up right now. For this activity, you're going to be using the program Kami. Remember that over here we have our text box, which allows you to go ahead and drop a text. If you want to draw on here, highlight on here, this will be the area to come over here and look. So you're going to work through this, and notice that I've already provided you with another periodic table. Here's some base information, and you're going to answer these key questions. There's 8 of them. When you finish with that, you're going to complete 9 exercises, and then you're going to turn this in. If you would rather wait until you return to get a paper copy, please message me and let me know that. If not, please complete it on this program. That concludes everything that we did today, and I hope to see y'all tomorrow.